Hi everyone. I apologize for doing this in the video on demand format, but I try to minimize flights for talks. For background, I will just mention my father's family was from Poland, and I have a Polish citizenship and visited Poland and Warsaw in the past, so I'm very happy to give this talk as part of a conference taking place in Warsaw. I founded and led the NEC Research Center in Israel, one of several across the world, since 2016, and recently have left to start something new. In my talk, I will therefore not talk about specific details of commercial applications developed by NEC, but I will cover lessons and work that is academic or non-commercial and can be openly discussed. The photo on the right, by the way, is of a future Nobel laureate, Geoffrey Hinton, holding a python snake. I find that prophetic. So we start with the most important slide. Why should the listener care? The core application I will cover is how to gain insights from customer or user reviews for some product. It can be a book, a car, a hotel, or an online course teaching something. But customers do not work for us. Even if they choose to give a review, they write as they please or talk as they please on TikTok or other platforms. The advantage of open-ended text is that they often raise topics we did not expect. So while their inputs are usually very important to the provider of the product or service, it requires a lot of human analyst work to gain the insights and organize them to an actionable set of data. So after some background on LLM uses in business to business, I will try to convince you that traditional natural language processing methods are not suitable for deep and high quality insights in an open-ended review. That generative AI can be very effectively used for this purpose, and how to optimize and correct the use of the Gen AI for this, where I emphasize the words efficiently correct, meaning not too expensively. To avoid any potential commercial conflicts, as a sample case, I will show how a course review can be analyzed for academic insights, and maybe talk at the end about how this can be further extended and automated in the future. So just a few words about my background, which is centered around machine learning, but admittedly not specific to LLMs or even to NLP. My claim is that while technologies of machine learning and intelligence have advanced beyond recognition in the past 3 decades, some basic attributes of how machine learning or AI is done have not. Some principles seem to be universal. So, my first AI application was a three-layer feed-forward neural network fed with tabular data to assist in the motion estimation of sorted items on a conveyor belt in the 90s. Believe it or not, at that time it was hot stuff and cutting edge. I did work on object detection and recognition for mobile phones as part of my startups and then working for Samsung Electronics. And in NEC got to experience the then new deep learning technologies for computer vision, and then of course of large language models for application areas I will mention and list soon. And all these truly fun and diverse projects, some for defense, some for consumers, and some for enterprises, in so many fields, led me to a simple conclusion. First, process and method are always more important than using the latest new technology or algorithms. Even today, a logistic regression model with good data and controls over when and where it is applied can beat the latest giant LLM in many things. Knowing the specific problem area and what the customers demand and is willing to forgive is the most important thing. Second, something I still often hear from less experienced data scientists is that when the customer is complaining about some errors or disagreements with the AI results, The customer should simply provide many training examples for this edge case, and then the data scientist can fine-tune or retrain the model. Worse, if the new model is still not solving the problem to the customer's satisfaction, the customer should get even more data. I can honestly tell you from 3 decades of experience, there are very few things customers hate more than having to work for the provider. That is especially true when the provider, in their frame of mind, made a faulty product. So you don't want to go there. Simple as that. Before we go deeper, let's overview how LLM-based AI is used in businesses today. The most common is actually a business consumer. That is, an employee who is using a hyperscaler LLM like ChatGPT, Gemini, Claude, or programming tools like Cursor to get their job done. The employer may pay for the service and negotiate a special SLA or some privacy protection measures for their employees, but that's about it. However, in parallel, many enterprises are trying to put bespoke LLM applications to use internally, where the LLM is more of an assistant to the employee for retrieving information, accomplishing some data manipulation or formatting task, etc. So, based on things I've seen and have done, here are some key applications of the second kind, where the LLM is an assistant. For example, categorization of documents for sensitive information. Very important to avoid commercial information leaks. Another example, compliance checks in legal documents and sales communications. Very popular in legal and banking. Those stem mostly from regulation. For example, in the banking industry and investment advisory and insurance industries. Task-oriented summarization, to differentiate from generic summarization. Task-oriented means rather than a general summary for everyone, you want the LLM to extract specific types of information which depend on the purpose of the person reading it. So for example, action items for a SOC operator based on reported vulnerability or CVE. Clearly, the summary for an IT staff operator or for her manager or for the CISO of the company or for the chief legal officer and CEO need to be very different. Fake news detection based on comparing sources, whether they say similar things. Unstructured text to tabular data. That is an activity sometimes called in the industry ticketing, routinely done by humans in areas like healthcare, insurance, customer support. Textual statements, fact extraction and comparison for detecting incongruencies in the data. A good example is civil servant reports or testimonies that need to be presented in court. You want to catch in advance automatically simple factual errors like dates, locations, or names. That's very menial work, and LLMs with the application can do it. Another one is fact extraction for trend detection, which in some ways is also open-ended like customer reviews. And one which is growing very much now is code inspection. While everyone is talking nowadays about tools like Cursor for writing code and completing applications, that is a very real use case, of course, of the first kind, B2C, if you will, because the programmer is using it paid by the employer. But I'm referring here to cases where the organization wants code or configuration files reviewed by some AI to ensure security or compliance with some policies about documentation, about error correction, and so on and so forth. So as you can see, there's plenty of B2B applications which do not rely and do not necessitate the user reading the output and progressing in the prompt reply sequence. If you look at the previous list, or at the low-risk proven value applications of AI in healthcare in the infographic below, what they have in common is that indeed they are not a sage in the machine cases where superior intelligence or AGI is expected, but rather tasks you would typically delegate to assistants or lower level employees of the organization. I code them as REST, repetitive yet essential, standardized, meaning the rules are well defined, usually written, and time consuming for the T to do manually. These are the most natural places to start implementing bespoke AI for an organization. So implementations and implementers of B2B commercial applications have the following challenges. 1. Decidophobia. If new and better LLMs come out every day, why should I commit as a customer to a solution now? Will it make me look incompetent when a few months from now my bosses find a new readily available better product out there? Second one, hallucinations. We don't really understand LLMs, unlike traditional software. Sometimes they give totally imaginary results which are totally incorrect. And of course, the less talked about issue of irreconcilable differences. This is not really mentioned enough in the literature. It is a case where the worldview or the knowledge of the LLM is simply different from the one you need. To give a banal example, some LLMs will say the color of the sun is yellow and some that it is white. The latter might be more scientifically correct, but not what you want. And this is a result of the texts they were trained on, for which you have very little control or no control. Here is a real life example of an LLM, ChatGPT 3.5 in this case, having views or opinions that are not compatible with our purpose for the application. As part of a proof of concept for a project of processing social worker reports and converting key information to tabular data, we constructed imaginary test cases. As you can see, the LLM made a decision about the risk of actual severe physical violence in an imaginary case we constructed, which we feel was not appropriate. Even as we tried to force the LLM to accept some premise, we failed. Just like a human employee, it had a mind of its own. How do you handle this? I will just mention that later versions of ChatGPT did not present this issue, but as you use local or on-premise or just different LLMs, issues like that will occur. Sometimes the LLM will have some internal opinion or view which you need to change, and maybe you can't. The opinion worldview of an LLM we did not build from scratch is a function of the text it was trained on. Here is another rather glaring example. 12 hours after the famous and disastrous debate between then President Joe Biden and current President Trump, we asked ChatGPT about the debate. We were interested to see what's the view. I think all of us will agree the report it provided seems to miss some key points about the displayed mental capacity of then President Biden. But when you look at the sources it cites, it makes sense. The sources it used indeed failed to mention this in any meaningful way. This issue can manifest itself even in very mundane business processing tasks. For example, the LLM may misinterpret phrases or meanings, especially when dialects or company-used dialects are used, or when the user is not writing or speaking in her native language. In all of these cases, the way the LLM interprets the sentence or the meaning might be different from what we want it to do. Now, among deep learning practitioners, especially people who come from academia, the common wisdom is that if the LLM does not do what you want, you can train or fine-tune it to fit your purpose. This is somewhat true, but requires a lot more effort than many understand. And worse, there is no guarantee of success or measure of how much the success will be. When you have a bug in your code, you are supposed to inspect it, think and fix it, and be done with it. With any machine learning or AI process, this is not exactly the case, is it? To debug, you may need to get or create a large set of new teaching examples, training sets for text. And even assuming you did all that for all the error cases, the training may not fix the issue completely. Or even worse, it may create new issues in things that were working before. This is an inevitable side effect of loss function-based optimization, which is the engine behind LLM training and deep learning. And anyone working with machine learning knows it. But customers have a very hard time accepting this. So do we. When our car or ERP systems have a fault, we don't expect the mechanic to ask us to drive the car a few hours so he can train something in the engine, and we expect to just get it back fixed. So we should sympathize with our customers for our AI algorithms. Now to our solution. We use LLMs to answer questions about text we supply them with. Think of LLMs as a person under sedation, shock, or non-cooperating. Interrogation is used by medics, first responders, policemen, and reporters to get the required information and get it reliably. You ask many short, clear questions, often overlapping, even repeating, with clear yes or no or multiple choice answers. LLMs tend to be accurate when given precise questions that relate to the text provided in the prompt. Single-shot prompting or retrieval augmented generation. An ensemble of many partially overlapping prompts improves accuracy. LLMs cannot or have a hard time hallucinating when you force the answer format and length. To fix errors and update policy, we change the prompts or add new ones, new questions or new comments in the questions. This may seem like tedious work, and it's definitely human-led, but in reality, in actual situations of products, LLMs have amazing demos where everything seems to work well, but they fail when you have massive automatic operations, where even 5% of errors is too much. And we claim that our programming approach, constructing short, simple, multiple choice questions, providing only the relevant information, can give you much better reliability at the price of requiring more work. So let's go over the processing and data flow situation in this approach. We have a given short text, a review, an email. We use an LLM API to ask several yes, no, or multiple choice questions about the task and concatenate the results into a vector of numbers. We then employ a simple classifier for the final decision. So in a way, we have broken up the process of the LLM into smaller parts. Rather than say, what is your opinion or classification of a text? We instruct it to ask and answer many questions about the text, and then we make the final decision with our classifier. This gives us several benefits. The LLM is plug and play. We can upgrade, fine-tune, replace with ease. Just rerun on the test set to recheck the classifier and the accuracy. In practice, we may need a larger ensemble of question prompts when the LLM is less sophisticated. For example, open source or on-premise one, which we use for security, speed, and cost. While the latest hyperscaler LLMs may get it done with just one long prompt where we concatenated all the short questions and instructions. As for the classifier, the simple structure and human understandable input provide several advantages. First, the classifier can typically be bootstrapped as an and/or decision tree based on common sense. So as humans, we will just tell it what to do. For example, if you have several trigger conditions that even if one of them is a yes, the final result is a yes about the text, then it's just an or function. Second advantage, debugging of prompts and logic is easier. Errors can be traced to errors in the replies of the text of the LLM to the questions or in the logic of the classifier. Special cases we encounter during testing can be handled with specific human-controlled logic. For example, let's imagine we are scanning corporate emails for some sensitive deal information to make sure it didn't leak. If the email is about finances, but it is about personal finances, which is a different question, then we can instruct our classifier to ignore this email. It's not important for our purposes. Let's walk through a quick demo you can try yourselves later. One of the most valuable gifts the United States government ever gave natural language processing research world is the Enron email archive. Enron was a publicly traded company that imploded in 2001 after a vast, long-running campaign of financial fraud. It was a big thing at the time. And all the emails are available online. Now, picture aiming a large language model at that mountain of messages and asking it to flag the ones tied to planning or perpetrating the fraud, keeping it running or covering it up. Most of the emails are mind-numbingly ordinary. Office party logistics, weekend plans, personal chit-chat. We don't have time to read them all, and simply prompting the LLM with a question like, is this email about fraud, will not cut it. It doesn't have the world knowledge and the corporate knowledge. Even if you pad the prompt with a definition of fraud or toss in a few fraudulent examples, the models still stumble. Why? Because people arrive to work with a lifetime of real-world knowledge. How people talk, how they scheme, how they hide things. That kind of intuition is fiendishly hard to cram into an LLM, and there are very few datasets, like the Enron one. So here is the trick. As you can see at the bottom of this slide, we create a long checklist of yes or no probe questions or interrogative questions. Little linguistic tripwires we hope the model can answer correctly most of the time. The real list is much longer. It can be dozens, sometimes over 100 questions. And you don't have to dream them all up at once. Start with a handful, run the system, spot what it misses, then add the next batch. Think of them as lines of linguistic code that catch every corner case the model skipped the first time, just as if you were instructing a hardworking new assistant to do the same. Now, even when we engineer our prompts with surgical precision, large language models are not obligated to answer in the format we requested. It's a mundane fact. They may reply with a yes in lowercase, uppercase, sprinkled with a period, say positive instead of yes, or start rambling in a full paragraph instead of giving our desired crisp yes or no that we need. Remember, there is no patient intern reading the output and tidying it up, like when you use an LLM personally. The whole pipeline has to run hands-free, exactly like ordinary computer code. So, before it emits each word, an LLM conjures up, as you may know, a cloud of probabilities for every possible next token, and then it picks one, often by a simple greedy max probability rule or by some other logic. That behavior gives us an opening. We use masking. We hide every token we don't want the model to consider and leaving only two single-word options, an unequivocal positive or negative. In effect, we force the model into a narrow bridge where the only possible footsteps are yes or no. I will note that the latest hyperscaler LLMs like OpenAI's don't have this issue anymore. They almost always give you a yes or no at the start of the reply if you specifically ask for it. But other models are not so easy with that. Now, what to do once you do have an error that you discovered luckily yourself or that the customer came to tell you about. Debugging is part of every coding environment, and LLM workflows are no exception. Yet with an off-the-shelf language model, classic single-step debugging is almost impossible. There's no built-in way to trace why the model gave the answer it did. Even the chains of thought don't really affect necessarily the result. Sure, the big vendors, OpenAI, Google, and Microsoft, are racing to bolt on citation features that justify facts with external evidence. But when it comes to explaining pure reasoning, most LLMs still struggle. In a B2B setting, we'll probably be running a more constrained open source model or on-prem in a private cloud, so the challenge is even harder. Breaking the job into smaller pieces like we do is how we get our grip back on the reasoning and on debugging. When a classification result comes out wrong, the first thing we inspect is the model's answers to each of the small micro prompts or ensemble prompts. If a few of those are off, we ask whether the error is model specific or systematic, because we can try other models easily. Then we sprinkle in additional closely related prompts and let the ensemble vote, much like asking a sleepy colleague the same question 3 times or in 3 different ways to jog their memory. For example, instead of one broad prompt like, does this document concern legal issues? We fan it out into prompts about litigation, contracts, court filings, letters from attorneys, cease and desist letters, etc. Occasionally, the glitch is in the classifier layer itself. That's a classic programming bug. Given a specific vector input, the classifier must return a specific output. That's easy to fix. The headline, the takeaway from this is that we never have to do the thing I warned about at the start. We don't have to go back to the client hat in hand and plead, could you send us more examples so we can fine-tune our LLM? Trust me, avoiding that conversation is priceless. Let's test it now with a live example. I'll let you for a few seconds read this brief email to Wanda in a corporate. And as humans, we immediately feel the vibe. It's personal, it's not a boardroom negotiation. The writer of the email is clearly hoping for or hinting at a promotion that will lift their finances. GPT-4 models are sharp enough and human-like enough to catch this subtext. GPT 3.5 and many open source LLMs miss it entirely. You'll bump into cases like this again and again when you deploy real LLM pipelines inside the B2B settings. All kinds of fine cases where humans, even not very experienced, will have no problem understanding it, but LLMs like someone from a different planet will not. So, when we have an issue with an error in the LLM output, in the machine output, we have 3 choices. We can try to upgrade to a hopefully smarter LLM and we can tell the client to just live with the glitch. Not a good idea. And the last option, to do what programmers have always been doing. Apply a surgical hack and patch the edge case ourselves. In this scenario, we drop in a custom prompt that sniffs out any text hinting at HR changes for the writer of the email. In a perfect world, the model would be sensitive enough to realize that every mention of a job title, rank, or status makes the message personal rather than corporate related. But we do not live in a perfect world, and LLMs are far from perfect. So as you can see, we have to try and solve these cases ourselves or think about them. So now, as I promised you at the beginning of my talk, we will move from simple text classification to more complex insight extraction from open-ended texts. A good example of open-ended texts is customer reviews. Now, the scientific method of open text analysis in mass is called qualitative research, and it's used today in areas where the human experience is complex and varied, so simple multiple choice quantitative questions are simply insufficient. While it is a very well established and widely used scientific method, this is a very human intensive process that is applicable to tens or low hundreds of interviews at best, takes months, and is definitely not practical for large scale. It's good for academics researching some problem and having target groups. Over internet scale of hundreds of thousands or millions, it's impossible to do economically. When we examine the pre-LLM natural language processing methods, they are not semantic enough for deep insights. There has been extensive use of NLP for sentiment analysis, but the sentiment is generic to the review, and the same review may express both positive, neutral, or negative sentiments over various aspects of the product or service. The Gospel of Matthew says that the flesh is weak, but the spirit is willing. So is the sentiment weak or willing? Tools like keyword maps are good for detecting topics and trends. So for example, more mentions of a new technology as time passes, but as they do not provide the actual intention of the mention, are the users happy with this new technology? Do they demand it, expect it? Are they complaining about it or comparing it to another? You cannot extract this kind of insights from a keyword map, neither from a generic sentiment of the whole text. So we use a mixed methods approach. First, we define key topics or themes based on keyword maps and or human analyst decision or management decision. Then we construct the prompt ensemble to cover the aspects of the themes you are interested in. As an example, consider reviews of an online course teaching programming. If you see a lot of mentions of out of date and updated, you may want to see if users comment on the course material or the exercises or the programming language used itself or the tools. Usually, the first prompt ensemble will miss some cases, and you can iteratively debug using human logic, just like I outlined a few slides ago. A simple example is the von Restorff effect or distinctiveness effect. If a course is hard and requires a lot of self-study, some people may openly talk about it, others will just not mention it. But it will be very rare to see a review saying, "I did not need any help, all the material was clear from the lectures." Similarly, in a car review, people may complain about the dashboard being plasticky and squeaky, but they will not usually say the dashboard was very quiet. For reliability, one should always try to use triangulation. Find different measures and independent signals that support the same conclusions. For example, if we see a repeating user complaints about a specific aspect of the product and we believe it is important to them, then we would expect that the average numeric score rating they give the product will be statistically different from the one users who did not mention it gave. We expect a correlation. If 3% of guests complain about insufficient hotel towels, but their average rating is higher or equal to that of customers who never mentioned it, maybe it is not a critical factor. We now show a case of a relatively complex product. Online courses teaching STEM topics like programming, data science, etc. Such courses have been very popular with millions of learners worldwide and on several online platforms like Coursera, Udemy, and edX. The numeric scores by learners who complete these courses tend to be very high, 4 or 5, and the bulk of reviews tend to be very positive, expressing happiness at having finished the course and positive about the experience without much detail. However, the actual measured dropout rate from the courses is typically well over 90%, so only 1 in 10 or less actually complete it. It is therefore a challenge to try and extract the meaningful comments and hints from reviews to see what are truly the major issues that cause dropout. It's very similar, by the way, in academic settings when you have student reviews of the courses. They would tend to complain about things like the lecturer or the course material, but there would be a very strong correlation between the complaints and the grades or the difficulty of the course, which makes analyzing the results and getting the true issues much harder. So this existed before the internet and before automation, but it still is there. As I list here some of the challenges, look for a moment at the sample reviews here. They are far from the worst ones in terms of logic, flow, and grammar. There are much worse reviews you will have to process. Now, have a moment and take a look at them. The first two actually talk about the same issue, the need of the learner to autonomously seek information and help to complete the course. When the first reviewer writes the forum is very good, he is not talking about the IT aspect or the UI. He is clearly indicating the forum is a good place to seek answers in the context of his review. This is clear to a human or a well-made LLM, but it is not clear to a simple NLP algorithm. The last two reviews, longer ones, talk about a claimed disconnect between the course material and the final assignment. But note the very different language, detail, and sentiment expression. This is the real life of the review analyst. People write in the order of their thoughts. They do not edit. They are not necessarily native speakers of the language, and they may be very upset or very happy, and that clouds their logic and thinking. And you still have to try to glean in some insights from their reviews. Here is a sample prompt. Look, it's very long. Used to search for positive mentions of the autonomous information seeking activity while taking a course. Note the complexity of the prompt and the numerous cases. In this case, we did not use an ensemble because the latest OpenAI 4X models are able to handle this full prompt well in one take most of the time, like over 99% of the time. While smaller models would need it to be broken into a set of shorter prompts with a final classifier like I outlined before. Please also note the directives, bold here, about avoiding speculation, sticking to the text of the review, and the request to explain the answer of the LLM. The explanation from the LLM is used not just for statistics, it is important for debugging, and for some reason also seems to improve the accuracy of the yes-no answers, at least with the ChatGPT family of LLMs. So having to explain themselves somehow seems to make their answers slightly better or more accurate. After running the original query and finding misclassifications, the following lessons that you've seen were implemented. First, as I said, explicit mentions and use only the review text. Since in some cases, when the review mentioned how hard the course was, the LLM deduced by itself that if the reviewer says the course was very hard, they must have used help seeking, even though they said nothing about it. These kinds of deductions are not what we are after in our scientific or commercial analysis, so we insist explicit mentions of help or information seeking. However, if people mention important information was missing in the course, they must have done some seeking. This is our logic as analysts dictated in the prompt. Other people may say this logic is wrong and do their research without it. That's part of the, let's call it, analyst decision or management decision when you analyze reports. And yes and no first to make it easier to get the numeric value, and only then an explanation. As customers' reviews usually also include a numeric score, one useful method which I mentioned earlier is to triangulate our results of sentiment towards something with numeric score. And I give you an example. We take two very common aspects of reviews mentioned in 5 to 10% of reviews in courses of this nature, so a lot of times. The one is the need to seek help or additional information, and the other one being complaints or mentions that the course material is out of date or has errors, broken links, etc., which is very common in IT and programming related courses. The sentiment difference towards the two is clear from the LLM analysis. So we know what the LLM thinks people think about it. But we want to have a different analysis show the same trend. And indeed, the score distribution between those mentioning the two issues are markedly different. In the charts below, you can see the average course score among those who mentioned help seeking versus those who mentioned course being out of date. Over 10 course specialization in data science and a 5-course specialization in Python programming. So this is a very marked difference of over 1 or even 2 grades from the scale of 1 to 5. And it comes with perfect correlation to what we see in the sentiment people express in the text. So, to sum up, we have presented a programmable prompt approach to some B2B LLM applications where we need automation. These applications run over large text collections, which may be continuously generated if you're a live website or a course. There's no human oversight, and hence they require much higher accuracy and reliability to future input changes and to customer failure cases. We accomplish this by breaking up the LLM operation to smaller parts that can be tested and debugged separately. Another benefit of this approach is reduced dependency on a specific LLM and avoiding the need for customer-supplied datasets for the fine-tuning. I hope you managed to get some new insights and interesting facts from this talk. And if you want to follow up the discussion, you can ask for the conference, and you have my email on the first slide. Thank you very much. I really hope people will enjoy this and learn from this. Have a good week.